Hello team, this is we're going to talk about power and cooling in data centers. So data centers use a lot of power and operators try to make sure that power is cheap and is available at all times. So it's usual for data centers to have different sources of power like independent circuitry and possibly buy power from multiple providers like multiple companies that sell electricity. Data centers may be located at locations where power is cheap because they use a lot of power. So if you can buy power cheap, that's good. And you might not be able to place a data center anywhere just because data centers draw so much power that you need to have enough energy so that you can operate the data center. So this constrains a little bit the locations where we can build data centers. Data centers also have batteries and generators so that if a power failure occurs, then the data center can switch to generators for some time until power is restored. And some data centers rely on renewable energy. For example, Google has a plan to operate 24/7 on renewable sources by 2030. And Switch actually operates on clean energy entirely. Now, using power generates heat. This is unavoidable. Even though components get more efficient every year, like CPUs and graphical units can make more computations using the same amount of power, they still use power and they still generate heat. And this is why our computers have, coolers. Depending on the graphical unit you have, you might have like 3 fans on the same GPU. So this is just to, get heat out of the device. Because data centers are so dense and have a lot of CPUs to generate a lot of heat, and cooling can get very expensive. Like running ACs to cool air is very expensive. So data center operators try to minimize how much they spend on cooling, and to do this, they design new technologies and new ways to cool the data center. Reducing costs is one factor, and also if you have efficient cooling, you can pack more servers in the same amount of space, and this allows for more cost-effective data center designs. Okay, so rack equipment is designed to take cool air from the front and exhaust hot air on the back. This is, the general design. And even desktops might do the same. So if you have a computer with multiple fans at home, it usually takes cool air in the front and releases hot air on the back. And this is more or less what it looks like. You have these grills in the front, and then the fans like this fan over here, this fan over here, and this fan over here, and this fan over here. They pull cold air from the front, and then you have more fans on the back like this. These are the power supply units. They also have fans, and then these fans also pull the hot air out. So the hot air goes out on the back of the device. And it's very important that hot air coming from one server or one switch, the computing device, doesn't get into another equipment, because otherwise you're going to have hot air going inside an equipment, and then that equipment might get very hot and then it might malfunction. So operators build heat containment zones in data centers. Because servers pull cold air from one side and release hot air on the other side, they align servers in racks so that cold air comes from one side and is released on the other for all servers on the rack and all racks in the row. And basically, we're going to have these hot aisles with hot air coming from both sides and cold aisles with cool air, on the aisle, and then the servers pull in the cold air from this aisle and release hot air on the hot aisle. This prevents hot air from one device from going into another device. Now, some regions in a data center might get very hot, and to deal with hot spots, operators, they carefully manage air flow control inside the data center to make sure that, hot air doesn't get concentrated in a single location. So they try to build the data center so the hot air gets, out of the data center somehow, and to distribute cold air throughout the data center as well. And if a rack gets very hot, or a pod, like in the center of the pod, if it gets very hot, one way to avoid hotspots is to leave empty space between servers. So basically, if we leave empty space between the servers, there's going to be less heat being generated in that rack, and there's also more area to dissipate this heat. We've seen this picture before, but I wanted to bring it back to show the chimney. So this, if you look carefully, so this is a hot aisle, this is a cold aisle, and this is a cold aisle. And the hot aisle has this, glass thing on top of the rack. So the hot air is coming out of the servers in here and from the other side as well. And then it doesn't have anywhere to go but up. So it's going to go up, and then it doesn't get mixed in with the rest of the data center. So this goes straight out of the data set through the ceiling. So, this just drives the hot air out of the data center. And this is a cold aisle, and we see the same glass thing on the aisle over. So it's not showing up on the slide because the picture doesn't take it, but you see the same glass thing in here. It also happens on the next hot aisle over there. And this is an example of racks that may have lower density to avoid heat. So we see we have two devices and then one empty unit, and then two devices and one empty unit. This may be by design to make sure that the rack doesn't get very hot. So this reduces density, and so we get less heat being generated by these racks, and it also allows for more area to dissipate the heat. Another thing that data centers do is use raised floors, and this is common in server rooms as well. So we build these, supports, and then the floor is raised from the concrete floor of the building. And then you can use the space on the bottom of the raised floor, below the raised floor, to pull cables. And in data centers, this space can also be used to pass tubes that carry cold air. So you can distribute cold air throughout the data center by running these tubes under the raised floor. This is one way to distribute cold air. And operators keep experimenting with new ways of dealing with heat in data centers. So Microsoft has an underwater data center project where they put computing equipment inside a container and then submerge it into the sea, and they just leave it running over there for some time. So they have this project, and this is another project also from Microsoft where they're running servers inside a liquid that boils at around 55 degrees Celsius. So the servers don't get very hot, and this liquid just keeps boiling all the time. And it's of course non-conductive, so this liquid doesn't interact with it, doesn't carry electricity, so you can just submerge the servers inside this liquid. So this might be an alternative way of cooling servers in the future.